time to review some area and perimeter applications here. So let's start with this area of this floor here. We've got a kind of rectangular-ish floor with some holes cut out of it. We need to find the area of the floor, the shaded area here. So we could do this a couple ways. We could either break it into like little rectangles and find the area of each of these and add them up. That'd be finding, 3 areas and adding. Sometimes that gets a little tricky to break that up. Usually in this case, it's going to be easiest to find the area of the outside and then subtract off the holes. So if you find this outside rectangle, then we can subtract off these little rectangles here. All right, let's try that. So that's going to usually be our best method. So the outside, the total area here, the total lengths, I should say, we need those. So this total length here, if we add 13 and 8, is 21. And if we add 8 and 18, that's 26 feet. All right. And then this guy right here, these little holes, this is going to be 8 by 8. So this area is 64. And this area here is 60 square feet. So we're going to take the big area and subtract off the little areas there. So we have an area, the area total. And as we're doing these problems, there's usually lots of pieces. So label what you're doing, kind of like I just did area total, like that. So we've got the outside area, 21 times 26. And then we'll subtract off 64, and we'll subtract off 60 from that. And this is one main idea that we're doing here is we're getting used to writing these area formulas. This is not an area formula in the back of the book, but we've put pieces together. Okay, and we can see there's the big area, there's the 2 little areas we're taking away. All right, so we've got that computed over here. Go to our calculator. 21 times 26 minus 60 minus 64 gives us 422. This is, by the way, Desmos scientific calculator. If you go to desmos.com and click on their scientific calculator, that might be the best calculator to use. There's the graphing one also. This one works kind of nice. It's all you need. You don't need the graphs. So 622 square feet. All right. Now we know we got 622 square feet, so we're going to see how we're going to make some tiles. We're going to cover that with little bitty tiles, and we want to see how many little tiles we can cover that with. They're 2 by 2 tiles. Okay, so we got some options here. We can change this into square inches because these are in inches, or we could change these into square feet. Now, if you go to square feet, these are going to be decimals. If you go to square inches, you're going to have a lot of square inches. But probably easier to work with a lot of square inches. If you look in the back of the book there, at our conversion tables, 622 square feet. We have conversion table, and that conversion table tells us that 1 square foot is 144 square inches. Don't use 12 because this is squares. So we got a big square foot, and if we find all the square inches, it's 12 by 12. So there'd be a whole lot of square inches in there. All right, there's 144 of them. So if we multiply that up, we get 89,568 square inches. Units are real important. Keep track of your units as you're doing this, so you don't start thinking you have 89,000 square feet. So the tiles are 2 by 2 tiles. So the area of a tile is 2 by 2, which is 4 square inches. And so the number of tiles we need is, we'll divide those. And number of tiles, this is the number symbol, not hashtag. It's not hashtag of tiles. No, we're not tweeting the tiles. 89,568 divided by 4. So we're going to need 22,392 tiles. That's a whole lot of tiles. Usually these kind of tiles would come bundled together, but that's the idea. All right. Like in a big square that's made of several tiles. All right. Calculate the number of linear feet of 8-inch wide hardwood that it would take to cover the floor. All right. So this one is a kind of a challenging problem because it's not turns out to be not too tough, but it's a little challenging. Think of it this way: we've got 89,568 square inches, and we're going to get some hardwood. Now, when you buy hardwood, you get these boxes that have a whole bunch of different lengths. And if you were to put all these different lengths of wood boards end to end, we'd have a big rectangle. And I'm going to kind of break it here. Okay, and this rectangle would be a huge rectangle, and we need to have a long enough rectangle so that rectangle is 5 inches by x. So we know 5 times x is 89,568. So if we divide both sides by 5, we get our answer. And that comes out to be 17,913. Just 0.6 inches. So that's inches. The questions ask us for square feet, so we need to divide that by 12. So we'll convert that. 12 inches is 1 foot. And that's going to give us 1,492.8 feet. All right. Now these are not square feet. That's why we divided by 12, not 144. Okay. So, good. Okay. Keep track of your units there. All right. Perimeter of the floor. Now, the perimeter of the floor here is, and we've talked about this a little bit, if we added up all these lengths, perimeter is the sum of all these lengths here, right? Okay, we're going to add all these up. Now, if we take these things here, and we got these 8 lengths, and we got to add up these 8 lengths. Well, instead of thinking of that length there, let's move that one out here. And instead of, let me zoom in here for you. Instead of thinking of this length right here, let's add in up this one right here. And instead of thinking of this guy down here, erase already. Instead of thinking about this one down here, we'll use this one down here. And what we see is that we basically need to, we just need to add up on the outside is what we're doing here, okay? So we're going to add up on the outside instead of that red one there. We're going to use this one. So all we need is we just need to add up the lengths to the outside, okay? And the reason for that is because this doesn't have a hole like this. If the shape of our building went like this trick would not work. Okay, see that little shape I just made there has some little holes that go inside. Then we just have to add up all the lengths. So we just need to find the perimeter, and so we're going to have 2 21. So we got 21, 21, 26, 26. So 2 times 21 and 2 times 26. So our perimeter is 2 times 21 plus 2 times 26. And that's going to give us 94 feet. So if you want to put some baseboards all around the bottom of the floor, we need 94 feet of that trim. Okay, there's those. Let's move on. All right, this next problem deals with a pulley, and we have this belt that goes around the pulley, and we need to find the length of it here, and it's got some rounded sections and some straight sections. Okay, so in the back of the book, we have a formula sheet. And this sheet will tell us the formula of an arc, the length of an arc. So the formula we're looking for is right here. So that's the length or the perimeter of the arc. So that's this distance right around the edge of this curve. That's L. So we have the angle, theta, that's the Greek letter theta, the angle divided by 180 times pi r. And that has to do with the circumference, or total circumference is 2 pi r, as we can see up here. All right, and so we're dividing by 180 because it ends up being pi around here, and we get a fraction of that. So theta over 180 times pi r. All right, and you can use that formula sheet on the test, so that's great. So we've got these different parts. Now we're going to build one. We're going to try to build one nice, neat formula. The length of this, we'll use L for length. The length of this whole thing is, let's go around. We have this arc right here, and that arc, let me highlight it. That arc there is 160 degrees out of 180 times, and the formula said, let me write down here again, length is the angle over 180 times pi r. So we have pi, and we've got the radius. It says the larger pulley has a radius of 5 inches, so this guy is 5. And the small pulley has a radius of 2 inches. So both of these, in fact, are 2 inches. So we have, there's the large one, plus we have this little guy here, that's 40 degrees. So we have 40 degrees out of 180, and that's times pi times 2. And then plus, we have the smaller one down here. Let's get this guy in there. 120 out of 180. And that's pi times 2. So that's all those curves. Now we've got to add in the straight sides. Don't forget that. I often forget those. So we have 10 inches, 18 and 20. 10, 18, and 20. So we've got to add in 10. We got to add in 18, add in 20. All right. So now we just go to our calculator and let our calculator do the work. So we'll open up our Desmos here again. Let's see if we can get both of these showing here. And I'm going to type it in just like it looks. We got 180 divided by, 160 divided by 180. And then we're going to multiply that times pi times 5. And we'll type all this in just the way we've written it. You actually, when you type the pi and the 5 on a scientific calculator, you don't actually need to do the times. If you want to, you can, but there we have it there, and I'll type the rest in. And there we are. There's all the pieces typed in there. Now, again, we don't need these individual little totals, the little subtotals. So we just need the grand total is what we're looking for. So the parts and pieces is great, okay? Um, so we get 67.55. I don't know what it tells us to round to here. Doesn't tell us. So we'll go 67.55 is good inches. That's how long our pulley needs to be, or I'm sorry, our belt around the pulleys. All right, now we have one of these HVAC problems. Remember, we worked on these. Here the key is that the area of this rectangle here needs to be the area of this circle. So we have some airflow coming in here, and that air is coming out here. We want the areas to be the same so that the speed of the airflow is the same. All right. So the area at the top is pretty easy to find. And that's 5 times 12, which is 60. And that's 60 square inches. Now, the question is, how do we find the bottom? Well, we know that the area of the bottom is pi r squared. So we got pi r squared has to be equal to 60. Okay, let's make that look like an r. And so we can divide by pi. And that's 60 divided by pi. Again, that's going to be a funny decimal, so let's just leave it as a fraction. 60 over pi. Pi is a number. Leave it alone. It's all good. We're still solving for r, the radius. And so we have r is the square root of 60 divided by pi. Now we can go to our calculator and we can check that out. Square root of 60 divided by pi. And it looks like we got 4.37. So the radius is 4.37. And the question here now is the diameter. So the diameter, we want to double that. That'll be 8.74 inches. And it says round to the nearest whole number. So round at the end. If we round at the end, we want 9 inches. Don't round I was tempted to do it. Don't do it though. Don't round this to 4 and then double. If you round this to 4 and double, you'll end up with an answer of 8. We need to find the diameter and then round. That's 9. Now we want to find the area of the top of this washer. This is a washer, not like a clothes washer, but this is like a metal washer for a bolt. And we know that we got the sides, and we'll soon be finding the area of all of this. But we're just looking at the white part here. So the area of this white part that I'll highlight here. What shape do you see? We should see 2 circles, right? We've got a big circle, and then we have a little circle cut out of it. So we got the big green circle with the yellow part cut out of it there. So we know the diameters there are given to us. We can make those into radius. We'll need the radius because our area of a circle is pi r squared. So let's think about a formula here real quickly here. Let's get all of our pieces. So before we actually jump into the numbers, let's think about what we need. We've got a big circle minus a little circle. All right. So the area is going to be big circle. This is my big circle. That's a circle minus the little circle. All right, so there's my little formula for myself. Okay, so the area of the big circle is going to be pi r squared. What's the radius of the big circle? Well, the radius is 11 down here. So pi r squared is the area of a circle. I'm going to subtract the little circle, which is pi times the radius of 6 squared. All right, now we just need to go to our calculator, punch that in. Pi 11 squared minus pi times 6 squared. big circle minus little circle. Pi 11 squared, pi 6 squared. And your scientific calculator knows the order of operations. Minus pi times 6 squared. And it looks like we're talking 276.035, 276.035. Okay, doesn't tell us what to round to, so 035, it will leave that 2 or 3 decimal places is good. And so this is square millimeters. Don't forget your units. Units are very important. They tell us what we're talking about there. All right, great. Let's move on, find some more areas here. Our next problem is going to be with a steel design chart. All right, so these are kind of broken up. We have two different types of, we got beams and we got plates, so we got to treat them differently. When we have some beams, the weight of a beam, it comes from its length, like this 42-foot length. All right, so this is our type of beam, is a W6 by 16 beam. And so that tells us a code here. So we go over to our chart, which is on page 136. We're looking for W, which is the top one. W6 by 16, that's right here, top of it. Okay, now, really what's important to us is the description up here. This tells us what these numbers mean. These numbers, the first number is D, a dimension. So D is a dimension. The W is the type, okay? D is a dimension. It's actually the height. We really don't care about that right now. We just want to know the weight of it. Well, the weight comes from the thing that comes after the X, which we call by. So that thing that comes after the X is 16. That's what we really care about. So this is telling us it's 16 pounds per foot. And so actually we didn't really need to go to that chart for these, because the second number is the weight, 16 pounds per foot. And that's very useful for making sure that we have enough support on this, making sure we can put it on a truck and carry it, or lift it with our friend or whatever. So the weight is going to be 42 feet. And then we're going to multiply that by 16 pounds per 1 foot. And I'm writing out dimensional analysis here. You don't necessarily need to do that. It's really just 42 times 16, but this helps us to realize that we multiplied it right. And 42 times 16 is 672 pounds, all right? Maybe a little heavy for a couple people to lift, but maybe if we get, four people on this, 3 or 4 people, then we can do that. You could probably lift it, I'm sure, but might be a little bit heavy for me to lift by myself, just a little bit heavy. All right, but that beam is 672 pounds. Now, what about this plate here? Okay, so we've got a rectangular steel plate. Well, these are dimensions here. It's 24 by 10 inches, and it's 7/16 inch thick. All right, so we got to go over to our charts and look at 7/16. So we're going to want our 7/16 here, and that's 17.85 pounds per square foot. So this is an area thing. 17.85 pounds per square foot. I'm going to jot that down. 17.85 pounds per square foot. All right. And so we've got to figure out how many square feet this is. Well, this is in inches. Well, we're going to have to do some conversion here. So the area of the plate, the top of the plate here, is 10 times 24, which is 240 square inches. Okay, well, we need to find that in square feet. So we're going to need to multiply that by This is square inches. We know that 1 square foot is 144 square inches, and that's in our conversion chart in the back of the book also. Okay, and so square inches cancels there. So we need 240 divided by 144. And we get 1.6 repeating square feet. Now we know that we have 17.85 pounds per square foot. So let's go ahead and convert that. So we have 17.85 pounds per square foot. And that's going to give us 29.75 pounds. All right. So those are two problems there that they're different, they're separate. Now, if we were to take this little piece right here and glue this onto here so that we got a little paddle, little plate glued onto the beam. We just need to find those two separate and add them up to find the weight of the whole thing. All right, so when it comes to test time, we'll probably have a couple pieces glued together like that, or welded actually. And so find the pieces separate and then add up their total weights. All right, so that's how we use the steel weight chart. Lengths for the beams and area for the plates. Make sure you change that area into square feet first. Great. Well, I hope that helps, and I hope you're all feeling all ready for the tests there. And study hard and keep it up. Good luck. Have a great day.